Alright, so before we get to tabular integration method, the tabular integration method I should say, let's look at one more integral where we might need to apply some of the other methods we've been using so far. So, can you guys help me out? How might you approach this one? Does it look like a trigonometric substitution right away? No. Does it look like partial fractions? Well, of course not. What's that leave that we've learned so far? Integration by parts. And if you remember, I think we used integration by parts to come up with the integral of arc sine, didn't we? So I think the arc functions, that's kind of the way to approach them, is using integration by parts. So can you guys help me set that up? U dv, which one should we pick as dv?
dv is dx.
dv is dx. Why, Brandon? Because it'll turn into x at least. Just dx, right? Yeah. So integrate and you get x. I mean, we don't have much choice. There's really just one piece, right? We can't put arc secant here because we don't know how to integrate it right away. So that's not going to work. So we can put it here. I'm going to write it in the smaller version. And how does that integrate? Can you guys help me out? 1 over 2x, because you put the thing outside and then you have a square root. I think you go the thing squared first right next to it, minus 1. Yep. And I'm missing one thing.
By 2.
Chain rule, right? Times the derivative of the inside is times 2 dx. There we go. Can you see the trig sub now? I think you should. But let's put it together the right way. So now we can write this as equal to uv minus v du. So we're going to have minus 2x, this is du, over 2x root 4x squared minus 1 dx. Is that right? That's kind of nice because at least a little bit cancels, right? But you can get rid of those 2 x's, so it's pretty good. Those cancel out. And now it's trig sub time, so I'm going to write this dx up here. That is something that we can't do without a trig sub because there's no x anywhere for us to compensate for the x squared on the inside. So let's do a trig sub with that one. So here we go. Theta. You guys help me label my reference triangle.
One of the legs.
Think hypotenuse is 2x, Gabe? You guys agree?
Yep. Bottom is double square root.
You want to put the bottom as the square root thing, all right? And the other side? 1. Cool. So we're going to have minus what? Well, we don't have a whole lot going on here. So if we want 1 over that, what should we pick? Tangent. It's going to be 1 over the root. So we'll have that inside of our integral. Okay. So continuing right here. Where are we getting? So we got tangent was this over that. That's what we need. We need dx. So you guys said you wanted to pick sine. And when we approached it with sine, we kind of got a little bit of a mess. So Anna said
Just do cosecant.
Cosecant might be a better way to approach that. Yeah, because then we'll have 2x over 1. It's just 2x. So then we're going to take the derivative of both sides, like we said. So that's going to be negative cosecant cotangent equals 2 dx. We can stick that in. So we've got the tangent is this part, the 1 over root. So that's the tangent. And dx is, bring this to the other side, right? So we're going to factor out a positive 1/2 then. Does that make sense? Because it's negative 1/2 with that negative makes a positive 1/2, so let's put a plus. And then we're going to have a cosecant cotangent. So that's going to be plus 1/2 We can turn this into sines and cosines or whatever. I think I'm going to do that. So we're going to have sine of theta, and then we're going to have a cosine of theta. What's up? And then we're going to have, so sine over cosine, we'll have a cosine of theta. That's 1 over sine of theta. And cotangent is cosine over sine of theta. Okay, that looks better. So now we're going to cancel something out. We're good right now, right, guys?
Good.
Okay, so canceling, and we get cosecant theta, d theta, which is plus 1/2. And do you guys remember how cosecant integrates? Secant integrates is one of the pain ones. It's natural log of secant plus tangent. So this one, you could look it up. I mean, that's okay if you don't know it.
Cosecant plus tangent.
Is it negative?
No. It's probably.
It's negative inside, I think.
Cosecant is negative natural log of cosecant plus cotangent.
Okay, so it's negative natural log of cosecant plus on Anna. Yeah, so not one we really need to remember off the top of our head. Plus C. But remember, we have the other part from integration by parts at the beginning. So we have x arcsecant of 2x right there. So there's how you do that integral. So it combined parts and trigonometric substitution. Just put it on my desk. Okay. Katie?
X and theta.
Oh, we still have x's and thetas?
No.
That's okay. Cosecant's right there, right?
Yeah.
Good point. 2x and cotangent, do we have that too? Well, we don't, but we have tangent, so flip tangent.
Square root 4 square root minus 1.
There we go. Nice catch. Very nice catch. Okay. There we go. So let's move on to tabular integration. So these three integrals are maybe a little bit tough. There's all kinds of tabular formulas. Our textbook has some. There's all kinds of published tabular formulas out there for people. It's kind of, the only reason I'm showing you this, once again, it's not on the AP exam, is because it's kind of like computer programming. Computer programmers consult documentation pages to figure out how to do things in their specific languages a lot, and this is really like that. It's consulting a table of integrals to kind of figure out stuff to help you. So let's look at this first one. You guys have your Appendix B opened. It's in the back of your textbook, okay? So have a look at, see if you can find something that kind of matches this integral. It doesn't have to match perfectly. You're just finding something that you can match kind of and then use a U substitution to do it. So I'll let you take a second on each one of these. So if you're watching the video, I'm going to go a little bit quickly. You'd want to consult whatever table of integrals you have and try to match one of the forms up with each one of these integrals. You guys see that first one, something that's kind of like it?
Yep.
So I think you should find a formula like,
27.
Yeah, I looked at 27, but I don't know about the.
there's one like this.
Squared. But the things on the
X
inside are
squared.
squared, but I don't know about the outside. But it doesn't have an outside.
Yeah, I don't know.
The variable here is A or U.
You.
You can tell from right there, so A must be like a number, like a constant, right? So we've got a formula that tells us how to do this one. It says that's the answer for that integral is 1/2. And you know, a lot of these things in the tables were done with trig, so we're done with integration by parts. Those techniques were used to develop them, plus possible other more advanced ones. But anyway, so they shouldn't come from mysterious places. You should be seeing answers that you've probably seen before, stuff really similar. You guys see that one? 26, yes. So, how can we adapt that to do our first problem here?
All the plus or minuses, it says plus or minus in the book, and you're saying all minus.
Oh, because U would equal X squared.
Does it have plus or minuses in it?
Yeah.
Yeah, well, you can just adapt it to plus or minus. If this says plus or minus, though, and over here in the formula somewhere, it says minus or plus, if yours was minus, that would have to be the opposite of whatever it was if it switched from plus minus to minus plus. Does that make sense, guys? So watch out for that.
So how'd you get them all minus for this?
I just did that with that formula because we have a minus.
So if it's minus, then it's going to be minus inside the formula?
Yes. Yes, exactly. Exactly. Good question. So let's do a u sub. I think we can do that with a u sub. What is u in this case?
X squared.
X squared. We also need to say what a is. A in this case is what? Compare. 3. We got it, Kyle. And do we need anything else? We've got u's, we've got a's. Well, when we do a u sub, you usually need one more thing, don't you? Du. Very good. So du is going to be what? Just from this?
2x.
2x dx. So first, let's write our integral over there. This guy I'm bringing all the way over here, and say that it's equal to the integral in terms of u. Right? So just like we've done before. So we've got an x dx right here, right? So where's this 2 going to go? 1/2 outside. There you go. Just like we've always done. And then we've got the square root of u squared minus a squared, which is what we have a formula for. So you can see how I'm using the u substitution to make it perfectly match the formula. That's all I'm doing. So now I've got that that's going to be equal to 1/2 of the answer, and I just have to write it in and fill it in as I go. So we're going to have 1/2 times 1/2. Maybe we should say that that's just 1/4. What is u for us? It was x squared. Square root of x to the 4th minus 9. You guys get it? Obviously. Minus 9 natural log x squared plus square root x to the 4th minus 9. Take a little bit of time, but there you go. There's our first tabular integral, where we've adapted a known formula to do a problem that's very similar to that. Okay? So not on the AP exam, but very useful for thinking in terms of engineering and computer science especially. So very engineering-y as well. That's why I'm doing this with you guys. So let's look for this one now. Do we have a formula in our table of integrals that looks pretty close to this? Remember, it doesn't have to be perfect. Is it close enough to adapt it with a u substitution? That's the idea in this lesson. 33, Anna says. Why don't you guys have a look at 33? Let's see what the book said.
Oh, there is a lot more.
There's a lot, yes.
No, because that's...
Half a minute. You get 4 integration. A minute.
There's one early on you guys are missing that you should be able to do this with. It looks a little weird because it has an A and a B and a U. It's 17. Very nice. 17. There might be another one in there you can use as well. Sometimes there is. So we'll say formula number 17
Well, no, because it's
says this.
it's piecewise, I think.
You're using my bad comment. These are the kinds of things I tell my wife, and then she gets really mad. You guys see that formula, number 17? So let's try to adapt it with a u substitution. It doesn't look as similar to this problem as we might have, but I think it should work. So we've got an x outside, we've got an x inside. You guys see that? So maybe we should be thinking about it more as like this, bu plus a. That's what it was, right? Let me make sure. Yes, okay. I want to make a mistake. All right. So our u substitution, this u that we're going to be using is what?
Just x.
It's just x, I agree. A. What is A and what is B?
A is -1.
You guys agree with Derek?
And B is 1.
And B is 1. So this one's pretty adaptable. Like for instance, if we had a 2 here, or a 5, or an 11, or a 13, we could still use the same thing. If we had a 2 here, or if this was like -7, we could still use the same thing. That's the point of tabular integrals.
Okay.
Someone else has done most of the hard work for you. So du is going to be dx, right? So we don't have to worry about anything there. So we're going to say our integral over there becomes, that guy equals the integral of, we'll write it down right here, du equals dx. So we're going to have du, x is u, x is u, and then instead of minus 1 I should put minus a, and I should really put c, like that. I guess instead of, yeah, let's not.
Plus A should
Should be plus A because A is still negative.
Yeah, let's just be careful here. So let's just leave it like this, and then write it down. So we're gonna have 2 over the square root of what? Notice if you put a positive a in here, you're gonna have problems because like imaginary numbers. I don't think we're doing imaginary calculus. That's a whole other thing.
That's just 1.
So that's just 1, right? Because negative is positive. Good, because otherwise we'd be in trouble. And then we've got the arctangent of a was negative 1, right?
Plus X.
Plus x, because b was 1, all over,
One.
not negative 1, but negative 1. So square root of 1 is 1. So this guy simplifies pretty nicely to that. There you go. Let's adapt another one. So why don't you guys see if you can find something that looks like this. So you're probably going to want to look at your forms with e to the x this time, right? Something with e to the x in the denominator. Give you a second.
Oh, there we go.
Oh wow, there's a lot
If
of.
you're watching the video, try to find it yourself.
Oh, I do believe I have found
Number 84.
it. It is 84.
Yep.
You are correct.
84, you guys found it pretty fast. Nice. Okay.
We're getting better.
Very good. So 84 says
Yeah.
du over 1 plus e to the u, and that's equal to u minus the natural log of 1 plus e to the u. I think you can do this formula. This formula didn't come from anywhere special. It came from a pretty run-of-the-mill substitution, like some kind of u sub. But, you know, we're supposed to do it with the formula, so we'll do it with the formula. I'm glad you guys saw that you didn't need another u up here. Because that's going to be like the du part, right? Very nice. Okay, so for us, u is going to be
Negative x squared.
du is going to be, well,
Negative 2x.
so du over negative 2 is equal to x dx. So now our integral transforms, get this other one out of the way. Our integral transforms to negative 1/2. And then we've got x dx is just du, sweet. 1 plus e to the u, sweet, it matches. You guys did a good job. So the formula says that's equal to negative, well, this negative 1/2 isn't in the formula, it's just from our compensation for the chain rule. We're going to have u minus the natural log of 1 plus e to the u plus e. There we go. That should be enough to start you out on tabular integrals. If I have enough time, I'm going to stay after school today and show one more kind of tabular integral that kind of replaces doing integration by parts a lot of the time. So it's going to be like a repeated tabular integral.
See you next time.